know the facts about tornadoes, but meteorologists can detect the thunderstorm conditions that give birth to them. The presence of layers of air of contrasting temperature, moisture, density, and wind flow. Such combinations of conditions may generate a tornado. Usually, this does not happen. But when the clouds become unusually threatening, it is wise to take every possible precaution. That calls for forewarning. And it is the responsibility of the United States Weather Bureau to provide the public with information regarding the possibility of severe local storms, including tornadoes. Such advance notice can save many lives and even help reduce property damage. Radar stations scan cloud formations at varying altitudes to detect dense moisture patterns, the beginning of bad weather as a rule. In the Elmville network, trained observers were stationed about 2 miles apart, with the heaviest concentration southwest of the city. All were pledged to watch any questionable weather, to report promptly to the Weather Bureau any dangerous-looking storms. Mid-afternoon, towering thunderheads had appeared with a sickly greenish-black color. On Jesse Brummett's farm, a heavy rain was falling, and he came indoors to watch from his kitchen. Then, at 3:26.
This is Brummett, Mr. Powell. Tornado about a mile east of the wind pumping station.
A mile east of wind pumping station. Looks like a bad one. Okay, we'll take it from there.
This was it. Brummett's call gave Elmville nearly 30 minutes to get ready. Powell and his assistants issued an immediate tornado warning to all communities in the path of the storm. The exact location of the tornado was flashed to the nearest radar station, which began to track it. What they saw were echoes from a number of storms over a radius of many miles. But most important, the peculiar S-shaped echo of the tornado cloud Brummett had spotted. Now, they could follow its path and report any change of speed or direction. Meanwhile, warned by television, radio, and telephone, the public followed tornado safety rules. Those with storm cellars had the best protection. There was no panic, for this was an informed community.
One of the most promising tools on the horizon is phased array radar. Its rapid scanning ability lets NOAA researchers observe storms like never before. But will it be more useful for the National Weather Service? Will it result in earlier warnings for you? Let's find out what happens when forecasters go hands-on.
Still a pronounced three-body scatter spike.
The PREACE is the Phased Array Radar Innovative Sensing Experiment. We bring in forecasters from the National Weather Service, and we have them work cases, archive cases in simulated real time. And they issue warnings and update statements just as they would in the real world. So then that allows us to learn how the data is impacting their process. Is it of benefit to them? Does it increase their warning lead time?
The past couple years have been focused on tornadic storms that cause light to moderate damage. With current radar, the average warning lead time for these tornadoes is about 12.5 minutes.
What we found from 12 forecasters working events like that, their average lead time was 21 minutes. And so that suggests that having this rapid update data, say on the order of a minute, really can make a difference in getting warning out and giving people time to respond.
So far, so good. The experiment is set to continue annually and will cover all types of severe weather events. Learn more here and follow us.
Where there's lightning, there's a strong chance for severe weather. The revolutionary Geostationary Lightning Mapper, or GLM instrument on the new GOES-R satellite, will give forecasters powerful new data for when to recommend that people in a storm's path take shelter.
Lightning is more than nature's fireworks display. Research has shown that lightning is an excellent early warning indicator for approaching severe storms and the development of tornadoes. This data visualization shows actual lightning measurements captured by a remarkable array of ground-based lightning detectors, capable of tracing how lightning propagates through the atmosphere. From space, the intersection of lightning and its corresponding cloud fronts becomes clear. That's why, on the nation's new environmental satellite, called GOES-R, an advanced lightning mapper known as GLM will survey much of the Western Hemisphere for atmospheric flashes. According to GOES-R scientists, this technology could help provide critical minutes of valuable warning time in advance of approaching severe storms.
The mighty power of Mother Nature, majestic and untamed, beautiful yet dangerous. As danger silently approaches through power outage, loss of cell signal, even if electrical interference scrambles your weather radio, you will be warned. The world's first direct detection, personal tornado, lightning, and severe weather alert. Every second counts. Find out more at tornadoalert.com.